شكرا بروف أسماء. بسم الله الرحمن الرحيم. I would like to announce the beginning of the first session. The scientific session will be dedicated to radiology. It will be chaired by me, Dr. Raida Sadham, from the Department of Oral Medicine and Diagnostic Science at the College of Dentistry, King Saud University, and Dr. Ashwaq Al-Ruwaili from the Department of Radiological Sciences at the College of Allied Medical Sciences at King Saud University. We will be having 3 distinguished speakers, and at the end of this session, we will have a breakout room. So if you have any questions or discussions for the presenters, the appropriate time, and you will have a chance to do so, inshallah, in the networking session. The link for the networking sessions will be announced at the end of the session. Our first speaker, Dr. Al-Anoud Al-Saleh. Dr. Al-Anoud Saleh is an assistant professor at the Department of Radiological Sciences at the King Saud University. Her research areas are neural imaging, involves structural and functional neural connectivity, and structural and functional neuroplasticity associated with learning. Dr. Al-Anoud will be presenting a talk titled Structural and Functional Brain Changes Associated with Holy Quran Memorization. دكتورة العنود تفضلي.
السلام عليكم ورحمة الله وبركاته. أسعد الله مساكم بكل خير. أشكر دكتورة أو بروف أسماء على الانفيتيشن، ويسعدني إني أشارك في هذا السيمبوزيوم، وإن شاء الله إني أكون يعني أوصل علم نافع للجميع بإذن الله. Can you see my screen?
Yes.
Okay, just 1 second. Today my presentation will focus on the structural and functional changes associated with Holy Quran memorization. كيف ممكن حفظ القرآن يأثر على وظائف وتركيب الدماغ؟ I will give you a brief overview about what I will discuss during my presentation, a brief introduction, my research or our research aim and questions, literature review, methodology, result, and finally conclusion and future research. So, why is Quran memorization important? أو ما أهمية حفظ القرآن? Not only from a religious point of view, but in general, how does it affect on our brain plasticity? Does it cause any structural changes? And how we can link these changes with the cognitive function and also the brain development. So the main research questions focus on the structural changes associated with Quran memorization, and does this changes indeed different in Quran memorizers compared with the control group, and does it correlate with the psychological well-being؟ من ناحية هل يأثر حفظ القرآن يعني على وظائف أو تركيب الدماغ، وأيضا هل يأثر على من ناحية المقاييس النفسية مثل الذاكرة، اللايف ساتسفاكشن، الهابينس. The previous literature, I found some previous literature were focused on the memory training. How does it associated with cognitive improvement? And it shows a positive structural changes induced by memory training. Mnemonic technique, such as, for example, مثل استرجاع البيانات مثلا أثناء حفظ القرآن، هل فعلا يأثر على الذاكرة؟ تذكر النصوص أو الآيات هل فعلا يأثر على الذاكرة إيجابيا أو لا؟ I found only one paper that's focused on the structural change they use MRI to investigate the brain structure changes with the scripture memorization اللي هو قرآن. هذا البحث كان يركز على تأثير حفظ القرآن على تركيب الدماغ. And they found a link between reduced brain atrophy and they suggest that Quran indeed can protect the brain from neurodegenerative disease. لاحظوا أن فعلا حفظ ممكن يزيد الجراي ماتر، وهذا بدوره يعني تأثير إيجابي ممكن يقلل خطورة الأمراض خصوصا اللي تجي مع تقدم العمر مثل الزهايمر والدمنشيا. فالسؤال، هل يعني نقدر نستخدم حفظ القرآن مو بس من ناحية دينية، أيضا يعني من ناحية تقليل الأمراض اللي ممكن تصيبنا إذا كبرنا؟ طيب، research gap, limited study on Quran memorization and the neuroplasticity. From this point of view, we design our research. Our research involved 28 Quran memorizer compared with 24 control group, and they were young adults, their age between 19 and 25. All of them were right-handed and all of them were female. And we done that, or we did the recruitment in our college in KSU University, in College of Applied Medical Science, and in our lab using 3 Tesla MRI scanner. Also, we done the psychological assessment online. It was like an online survey. The participants have to fill it, and it involved different measures like life satisfactions, scale, happiness, and memory tests. And there were these are the criteria, the inclusion and exclusion criteria. For analyzing the data, we used image analysis tools, free server software, and this software can be used for structural images. And for statistical tests, we use ANOVA as we compare different brain regions across 2 different groups. So what does free server basically do? It's measure the cortical, different cortical measures such as the cortical thickness, اللي كثافة أو سمك الكورتكس اللي في سواء كان المادة البيضاء اللي الجراي ماتر والوايت ماتر، وأيضا يعطيني الفوليوم والثيكنس اللي الكثافة والحجم، وأيضا التوبولوجي شكل البرين هل يتغير من ناحية الكيرفتشر. it does indeed give me different cortical measures, and it do that automatically. We can at the beginning we convert the image, all DICOM image, that raw data we take from the MRI scanner, into NIFTY format. هذه NIFTY format يقدر يتعامل معها الفري سيرفر, and we write like scripts. It's already a written script. We use it in terminal, and we run the script, and it will done all these steps automatically. And these steps involve the skull stripping, remove where the program remove the skull from the brain, and then it's labeled into gray matter, as we can see here, white matter, and CSF. Then normalization. After that, segmentation, where the white matter is segmented, as we can see here, differently from gray matter and CSF. After that, it do the sphere atlas registration, where the brain is inflated to be like a sphere. يصير كأن مثل ما احنا شايفين هنا كأن كرة. وهذا سهل التعامل معه لأنه أدق، يعطيني قياسات أدق، لأنه يحولها إلى اللي هو utilize vertex triangle كأنها مثلثات، فيعطيني قياسات وميجرمنت أدق. More sensitive, and this will improve the accuracy and volume and the other cortical measures. After that, it will do the parcellation, and it will register to different مثل ما احنا شايفين هنا different anatomical area. إيش الريزلت من هذا الأناليسيس؟ راح يعطيني massive data, numerical data, as we can see here. كلها هذه أرقام كلها represent different brain region and different cortical measures. يعطيني مثلا volume، يعطيني cortical thickness etc. for different brain region. أنا أخذ هذه numerical value أسوي لها إيش؟ أسوي لها statistical analysis على حسب إيش research question حقي. Our findings were طبعا هي كانت huge data, but here I just present the significant one. We found significant change in three different brain areas involving the amygdala volume, the brain stem, and white matter cells. And this area does indeed involve in memory, as we can see here. طيب نجي نشوف الاريا one by one. بالنسبة للأميجدلا عندها رول في الإيموشنال الإيموشنال ميموري والميموري بروسيسنج. القرآن ميمورايزيشن ممكن إنه انهانس الميموري الأميجدلا عفوا بلاستيسيتي، ممكن إنه يأثر عليها تأثير إيجابي من ناحية تركيبية، ويدعم الميموري consolidation والemotional regulation. And this was previously found by other study. However, they use different memory tasks. Here we are using Quran memorization. In terms of brainstem, which has role in cognitive controls, the structural adaptation suggests to improve attentional control and sensory integrations, align with a previous study, which found linking between the memory and cognitive and the brain. بالنسبة للوايت ماتر اللي هي in other words the neural connectivity, the previous study was found strong or improve in white matter connectivity produced by training or learning. Here we found also the same increase in white matter may indicate that there is improvement in cognitive plasticity due to memory training. In terms of psychological measures, as I said, we have massive data. We are dealing with the global brain regions. Maybe here our result is not really significant. However, especially after Bamforoni corrections, the significant one, it wasn't, the significant p-value wasn't survived. However, we found some area was significant, such as the area in superior temporal bole and the frontal region as well, the frontals. And this area, as we can see here, is significantly linked with or correlated with the life satisfaction and Raven, which the Raven scale, which focus on the intelligence. So indeed, Quran memorization can improve the psychological measures. So finally, this draws us to our conclusion. We found Quran memorization is associated with a positive structural changes in the brain region related to memory with emotional processing. So في يعني تأثير إيجابي لحفظ القرآن على الميموري، على الكوجنيتيف، على مثل ما شفنا اللي هو اللايف ساتسفاكشن واللونج تيرم ميموري، يأثر عليها تأثير إيجابي. وهذه psychological measure تدعم اللينك between the psychological measure and the structural changes. It support our hypothesis. These findings support the idea and intensive memory training influence positively on the brain plasticity, but further study need to long-term cognitive and psychological impact to study the cognitive change with long-term training and psychological impacts. So for future research, we are planning to do replicate the study, but we will scan before and after memorizing Quran. Thank you for listening.
Thank you so much, Dr. Lanoud. Dr. Asma, do you have a question?
Assalamu alaikum. Yes, please. Since we have some time before the beginning of the next speaker, I thought maybe we can take some questions in the Q&A box. And I'd like to ask a question verbally, if I may. Dr. Lanoud, thank you for this beautiful explanation of how you processed your data. What I'd like to ask is, have you taken into consideration either during this present study or during your future plans, the age of the Quran memorizers? So do the brain changes differ if they memorize the Quran as children versus if they memorized it when they were adults?
Thank you, Dr. Asma. Yes, actually, the previous study that I've mentioned previously, they did the structural investigation on the a bit elderly people. Their age range was between 35 and 80 years old. Here, between 19 and 25. So maybe in the future, but the problem dealing with the kids in MRI machine is different, is a bit difficult.
No, I don't mean the age of the patient of the subjects during the study. I mean their age when they first memorized the Quran.
Ah, okay, yeah, I understand you. Yeah, this is, of course, it will be. I think it will be different. In younger age, it will affect differently in the brain when you compare it with elderly people or with. But maybe we can add this as for future research question, inshallah.
I do have a question. Dr. Asma, do you need to ask further?
No, thank you.
Okay, so I have a question. Thank you so much, Dr. Lanoud, for your informative presentation. I have noticed that the control group is almost double the experimental group. Is there any justification?
The control group was 24. And the Quran memorizers was 28.
Professor Hasib, can you please unmute yourself?
I would like to thank Mr. Pura for very nice presentation. And this novel study, quite novel study. My query is concerning the statistical analysis.
Yes.
Actually, I have seen there are two groups only, and she used the ANOVA test.
Yes.
And that is valid for more than two groups. So we cannot apply ANOVA if there are two groups. And my other question is concerning the specificity. Is this specific to learning Quran also, or if somebody is memorizing another book, another topic, so that there will be similar changes will be there, and whether these changes will be transient or these changes are like permanent, the time course of these changes. If she can highlight on these points.
Sorry, can you repeat the third question?
Concerning the transient, they are temporary, these changes.
Mm-hmm.
So whenever the subjects are memorizing, and these changes are happening that time only. And when somebody is not memorizing, so these changes will go back to the baseline.
Yeah, thank you, Prof. Hasib. Actually, regarding to the first question about ANOVA, here we use ANOVA because we are compared different brain region across two different groups. We can't use t-test as we're comparing different brain regions. For the
but in the
yeah.
table you give the data like this compared
Yeah,
to
here is just simple.
The first table.
Yeah, here is just Dr. Simple table for represent the significance results. Yeah, for the second question, is it temporarily or stay for a long time? Usually the structural changes take long time to appear. So not like functional. I have conducted a study during my PhD. The functional changes appear shows with the 3 days, whereas the structural changes didn't. So it's usually takes a long time, not like the functional change. Regarding to the third questions, you said, sorry, remind me, I forgot it.
That was this permanent nature. They are temporary. I mean.
Temporary.
And I would suggest one more point. If you are going to conduct anything in the future, I think it would be better if you collect blood samples and analyze like neurotransmitters.
Yeah.
Because if there are any structural changes, that means there will be some neurochemical changes as well.
Yeah, you are right. And also, I think you mentioned something about compare it with other memory task, right? Not only specifically for Quran. Is it similar with other memory training? Yeah, actually, we plan to do that. I think me and Dr. Ashwag, we discussed this before. So we will replicate the study and we will compare it between two different group who train on memorize Quran, and we scan them before and after. And the other group will, for example, memorize, do a memory task on other anything else, such as, for example, poetry or anything else. And we will compare.
Sometimes they are memorizing the student.
Yeah, you are right. Thank you for your comments, Doctor.
Thank you, everyone. Dr. Bendri had the same question. Thank you for answering also this question again. So thank you all for staying with us. It is now my pleasure to introduce our second talk of this session. Up next, we have a brilliant presentation titled Unveiling the Invisible Radiomics. Our speaker brings a wealth of expertise from multiple perspectives within the field, Dr. Khalid Tiro. He's an assistant professor in the Department of Radiological Sciences, and he's the manager of the bachelor degree program in medical radiological sciences. His primary research interests are in the application of computing and informatics technologies to overcome problems and challenges relevant to medicine. He did his undergraduate in King Saud University, and then he did both postgraduates in Dalhousie University. Please join me in welcoming Dr. Tiro to the virtual stage. Dr. Tiro, the floor is yours. Thank you.
السلام عليكم ورحمة الله وبركاته. دكتورة بس can you just verify تشوف الشاشة عندي اللي هي التايتل. اوكي شكرا جزيلا. السلام عليكم جميعا. جمعة مباركة. في البرزنتيشن عندي اليوم إن شاء الله أنا I'm not gonna go over any current studies. However, I'm gonna just take this opportunity to introduce the concept of using radiomix in research. Currently, we are working on establishing an artificial intelligence office at our College of Applied Medical Sciences, which is part of the main artificial intelligence program at King Saud University. So it's going to be really great opportunity to grab the attention of the audience toward radiomix and how we may be able to utilize them in clinical research. So first of all, you may ask yourself what is exactly radiomix and how we may be able to utilize them. So the short answer of the question is it is a form of image analysis using a huge amount of standardized data. But before I go deep into the principles, let me go over a few basic points to prime the subject. So as we were taught that to start a research, we have to start with the hypothesis to test it by collecting data for analysis and interpretation to see if our hypothesis was right or wrong. So if we want to apply this traditional method within the context of medical imaging, at the end, we hope to end up with a set of biomarkers. But keep in mind that the discovered biomarkers, they are just candidate biomarkers and require a lengthy process of validation, which I will cover later on in my presentation. So this method, this is what we call it, hypothesis-driven research. It is worth mentioning that this method has a limitation, as we all know, in which we have to perform a time and resources consuming validation process. So what is exactly a biomarker? An imaging biomarker is a biologic feature that is can be detectable in the image. The lesion itself serves as a biomarker in any image, but the minute details of the lesion serve as a biomarkers as well, and can be collectively be used to assess the risk of a neoplasm, for example, as we can see in the image. We cannot call a biomarker unless we validate it through a technical and clinical validation, in which in technical validation, we have to make sure that the biomarker is robust and can be used repeatedly by the researchers or the radiologists in general, especially when they read images. And the clinical validation, which I'm referring to, on how to use it and if it does reflect the clinical outcome or disease. And here is the challenge with the biomarkers within the context of medical imaging. So another issue that I would like to underline is that the medical images are phenotype. This is what we call them, phenotype, which means that all underlying issues are reflected in the image. Because in a routine image interpretation, we usually rely on the size, the signal of the, let's say, MRI signal, for example, and a few reflections here and there, which are different from the meaning of phenotype in genetics, because they define it as a set of observable characteristics or traits in an organism. But in medical imaging, within the context of medical imaging, the phenotype means that all underlying issues are reflected in the image itself. So the process of the clinical and technical validation is really expensive and time consuming. So this is why there is a paradigm shift in things became more data-driven. So we cannot rely on the old or traditional hypothesis testing method. Now we have to turn the process all around. So from data, we are expected to generate a new hypothesis. And we can apply technical validation during this stage exactly. So in the end, when we have a biomarker, all what we have to do is to clinically validate it, which I will discuss shortly. So what is exactly radiomics? Now I can say that after exploring the traditional research method, the concept of biomarkers and the issues related to the validation process, I think I can get you much closer to the true and accurate definition of radiomics. Radiomics is a new data-driven approach for extracting large sets of data, of complex data and complex descriptors from the routine clinical images, which can be done in an automated way with no prior hypothesis. And this is the brilliance of it. And once we extract the large quantitative parameters, we have to correlate it with something like an outcome or a gene expression profile. Keep in mind that this is a discovery research. It is not just a validation. So if we discover something, that does not mean nothing, so it's not meaningful at all. And this is why I like to use the analogy of the gold rush that happened in California. So where the miners, they used to find a large number of pebbles, but they had to go through a long process of examination to identify the gold nuggets in them. So the large set of data can be analyzed using bioinformatics methods and biostatistics methods as well. For example, texture analysis from histograms, co-occurrence of metrics, and fracture analysis, all to serve the goal and to define imaging profiles to be correlated with gene expression profiles, radiogenomics, or to be correlated with outcomes, for example, the treatment response or survival rate. So what is the process? How can we identify radiomix and how we can utilize them? So we have to go through 3 different steps. Data collection, in which a software data collection can be used to extract features manually or using AI. Routine images are fine. We don't need for special acquisitions for data collection. The second step is the data cleaning, where uniformization and enrichment of data can be done by adding genetics information and pathological information as well. It is really hard because you are dealing with retro data from routine images, not vice versa. And finally, the data processing, where bioinformatics and biostatistics methods can be applied and used. This can be done by reducing number of features by technical correlation, and it can be achieved manually or using artificial intelligence. So when it comes to data collection, let me use an example of CT scan patient population. Usually we identify a region of interest and define its features, or define it in 3 terms of categories, either in shape, texture, or signal distribution. And the initial region of interest may be identified also manually or by artificial intelligence as well. For example, if we're going to go over the shape basically will be self-explanatory. You will describe how the tumor looks like, and of course its surface volume, and if the contour is regular or irregular, and feed all the information to the software. The second feature of the region of interest, which is the signal distribution, which is a histogram-derived parameter. You basically display a histogram that shows the pixels intensities, and then identify the number of pixels that demonstrate certain intensities, which are predefined intensities. All can be calculated and demonstrated statistically through mean, standard deviation, or variance. So when it comes to texture, we check the gray level and co-occurrence and run length matrix. So in the histogram, we can identify the co-occurrence and what kind of pixels in the image, but we don't know exactly the relationship between each other. This is why we have to understand how pixels are distributed spatially. So we use these spatial maps in order to identify the run length and the co-occurrence and the distribution of these specific intensities, in order to identify a specific or a special patterns that can be useful. The problem occur when we have a large number of features in comparison to patients, which is the normal case. And in studies, we have usually tens of patients and hundreds of features. Statistically, if we have a lot of number of parameters in comparison to samples, this means that there is a high chance in making false discoveries. And that's why we have to go over the data cleaning. For the data cleaning techniques, there are several methods, and let me go over one of them, which is the machine-driven method, by using unsupervised and supervised methods to separate different features, which can be done by clustering patients with similar characteristics. I will elaborate more about the unsupervised method, which is called hierarchical clustering. The product of clustering is called heat map, which mainly used in genomics. So how can we compute the heat maps? We compute the distances between the area of interest, and then we identify the closest pairs and merge them all together and keep repeating the process until we end up with a visual representation of the features and the population. And then we can split the population into groups and ask if the patients in the groups have different outcomes or not, or at least correlate them with the genotype that we can get from the genetics. And then we have to eliminate all the what is giving the same information in order to reduce the number. And this can be done by correlation test. For example, we can go over the sphere tumors that has diameter, surface, and volumes, and eliminate all of them if they are equal or similar to each other, and evaluate the redundancy among all the features. We have also to be careful. So if we discover a biomarker that is the measurement of it's not reproducible. So there is no point of it. Therefore, we have to remove all non-reproducible features. And here it comes the importance of the technical validity, which can be done by an exploratory method, such as inter and intra-observer reproducibility. We can ask one radiologist to draw a region of interest, and ask a group of radiologists to draw the region of interest as well. And then we can go over the feature reduction based on the feature quality. So the challenges, there are many challenges associated with this approach when it comes or when we compare it to the traditional hypothesis testing. The problem right now we are facing that the studies and the results are not standardized, unfortunately. We like the usual way of doing research because it is traditional and logical, which we don't have at this moment when it comes to radiomics. We don't know exactly how to do it by ourselves. For example, the heat maps, and there is no a single researcher can do it by him or herself. It should be done within a collaboration team with different or multidisciplinary backgrounds, statisticians, physicians, health informaticians, etc. But issues can be solved by standardizing or standardization initiatives. The most recent initiatives was completed in 2020 with the focus on how to describe the features or how to report the results and how to validate the radiomics. They were aiming to standardize a set of 174 radiomix features, and they succeeded in coming up with a set of 169 radiomix features, which enabled verification and calibration of different radiomix software. The image biomarker standardization initiatives helped a lot in to to minimize the challenges that we are facing with the validation process. The detectable features are all similar, even within the same patient, but we don't exactly know if it is a matter of protocol or not. Let me just introduce, it's a free tool software that can be used, which is called the LifeX. It's an open source free tool that can be used to explore the radio mix, and you can use it in a set of data if you have it. Other problem that we have right now, even if we have the information on the PAC system, there is no way, there is no easy or straightforward method to extract the information from the PAC system. Thank you so much, and I hope that was helpful and interesting for all of you.
Jazakallah khair. Thank you so much, Dr. Khalid Hiro. We only have 1 minute left. However, I have to announce that Dr. Khalid won't be available for the breakout rooms. So kindly either raise your hand to ask a question which is in 1 minute, or type your question, please. I might be able to answer some of the questions since I have used texture analysis using LifeX before, but not all of the questions about radiomics. So please.
I'm sorry, so I have to leave. That's why. But my email, you can email me at any time. And if you are interested in artificial intelligence, please let me know. And if you would like to join our group at the College of Applied Medical Sciences, that's going to be my pleasure, inshallah.
Sure.
So if we have no further questions for Dr. Tero, we have the third speaker of the first session of this meeting, Dr. Muhammad Al-Arifi. Dr. Muhammad Al-Arifi holds a PhD in Health Sciences Medical Imaging Informatics and was a postdoctoral fellow at the Northern Illinois University and is now an assistant professor at King Saud University. Dr. Al-Arifi is an expert in health informatics and digital transformation with a focus on medical imaging informatics. His research includes enhancement of the management of medical data across hospital departments and bridging the gap between patients and patient understanding and radiology reports. Dr. Arifi work has been published in leading medical journals and referenced in influential textbooks like Practical Imaging Informatics. Dr. Arifi will be presenting his research in exploring the role of AI in enhancing patient understanding of radiology reports, perspectives from the radiologists, the patients, and AI developers. Dr. Muhammad Arifi, تفضل.
Assalamu alaikum wa rahmatullahi wa barakatuh. Can you just verify if you can see my slides here?
Yes, yes.
Awesome. Bismillah ar-Rahman ar-Rahim. First of all, Assalamu alaikum wa rahmatullahi wa barakatuh for everyone. And I would like to thank the committee member in this symposium or annual symposium for giving me the opportunity. And a special thanks to Dr. Asma Al-Akrish for giving me this also the opportunity. Yeah. And also thank you for the audience to be in my session. And for this, I mean, we're talking about the applications of AI in medicine, and we're talking about from the point of view of radiology. So yeah, AI will be. The AI will have a good or potential. Let's say positive effect in the field of radiology, but in the point of view that I would like to focus on is that we are trying to understand the patient. The challenges for applying AI to radiology report. I do remember when I was in my PhD, I was talking to my advisor about the AI about the filling the gap between radiology report and patient understanding. So my professor told me that, look, Muhammad, there is a gap, actually a huge gap, and it won't be filled like, I mean, for 2 years or 3 years, or maybe you, or by your PhD dissertation. No, it's going to take a long time, maybe decades. We hope AI can help. So we wait until the AI comes. So when I saw the AI and I see all of the challenges around the AI, I felt the gap is getting more bigger and bigger and bigger. So yeah, in this session, I would like, or ally to my research, and some of my research already published and some ongoing and under revision. And if I felt like, for example, if I need more numbers, I used external studies, and I cited here in this session. Thank you so much, and let's go and talk about the radiology report. So we would like to talk about the radiology report and improving the radiology report. We would like to understand the perspective of 3 people, of 3 sides. First one is the radiologist, let's say referring physician, and also the radiologist. And we would like also to understand the perspective of patients and absolutely the AI developers. So here we go. Let's just go with a little bit basics about the radiology report. What is the definition? It is the document that describes the findings from imaging exams, such as X-ray, CT, MRI, ultrasound, etc. It's written absolutely by radiologists. The purpose of this is to communicate the image result to the referring physician. Yeah, unfortunately, to talk frankly to you, I mean, it's been proved that by so many articles that the current version of a radiology report meant to the referring physician, not to the patient understanding or level of understanding of the language. So AI helps in diagnosis condition, guiding treatment decisions, and monitoring disease progression. Structure of the radiology report. It's very important to understand that structure. When we talk about radiology report, that means we have to see patient information, image technique, clinical history. When I talk about image technique, for example, is this imaging from MRI or CT? What kind of a slide? I mean, what kind of projection for the image? Is it from front to the back? So we call it sagittal, or from left, coronal and axial. So it has to be written in the report. So how the patient can understand these kind of terms, which is an imaging technique, and the size of tumor, etc. And clinical history and findings, which is the interpreted, I mean, the explanations of radiologists. So who use the radiology report? Let's say the doctors and patient and health care teams. So what is the purpose for giving patient access to radiology report? It's increase the engagement for the patient. And let's numbers talk. We found that one of the studies mentioned that 51.2% of the patient actively view their radiology report online, and 85% of patients wish to see their medical image alongside to the written report. Now, this is raise a big question. What is the definition of radiology report? Is it include only the explanation, or I mean the interpretations, or the image? So one of my studies highlighted this point, and to come up with the definition has to be including both, because that's what the patient wanted. So, and also 64% of patients want direct access to detailed, not just hints or something, no, detailed report explanation. When it comes to their health, patient want they want everything to understand their report, so they can share it with someone else. And 33% of patients use online portal to request explanation of their imaging results. So the impact of 21. So the impact of 21st Century Cures Act. We should read about this. I don't have much time to talk about it. I mean, this is the bill has been passed by the Congress in the United States in 2021 in the time of President Biden, and but actually. This sign started from 2013 in the time of Barack Obama. He signed this bill, and it's approved. It took a lot of years to prove it, but now it passed. And in 2021, I invite you to read about it. The patient no longer need to wait for the physician, so they will have immediate online access to their radiology report as a part of the medical records. The transparency can be empowering, but also overwhelming. So yeah, this is one of the bigger challenges. Patients now seek for simplifying explanation to interpret their reports. It is not easy for them to integrate with their and understand their report. Increased access has led to higher call volumes to radiologists for clarifications. I have met a lot of radiologists here in Saudi Arabia and in the United States, and I talk with a lot of European radiologists. All of them claim that they don't have time to understand their have time to talk to their patient, because the turnaround time that they took it from receiving the image to be written, to the report to be written, it took them a lot of time, and they don't want anyone to interrupt them while they are writing their report. It's very sensitive and it's related to their career. So this is one of the problems, and I struggle taking time from them to do my research. I was begging them to be part of my research. I was interviewing them. I did this research in Eskenazi Hospital in Indiana, in Indiana state in the United States, and Rochester in Minnesota in the United States. Also, so the radiologists face workflow disruptions due to the increased patient questions. So the question is, there is a gap. There is a gap between patient understanding and radiology report. Let's admit it. And this is a huge gap. This is not just a small gap. And it won't be filled for this year or second years. It might be a years. And with AI, I think the gap is getting more and more and more and bigger. So the problem, a lot of problems. I just summarize a little bit from the problems here in this session, and will excuse me for just minimizing the gap here, just because I don't have much time. So why the patients struggle understanding their medical report? One of the problem is the complex radiology report. It's not easy because the radiology report designed for health professional, not for the patient, as I mentioned earlier. Medical terminology, jargon, and technical terminology, it's not easy for patients. We are talking about Latin way for writing some of the medical terminology, like the kidney, or it is not like we don't call it like kidney. For example, a lot of the radiologists use the terminology for this for the kidney or the liver. For example, heart, we know the heart is the word of heart. They use card, and then put I, or then it has to be like cardiology, like the knowledge of the heart, or someone specialized in heart. So it's not going to be easy. So the average American read, if we talk about the English version, at the 8th grade level, but the radiology report now is written in 13th grade level or higher. Can you imagine that for someone who doesn't know anything about medicine, 13? Or imagine if he is in the high school or elementary school, whatever. So patients often feel there is a confusion and anxiety and misinformed after reading their report. So let's numbers talk. Only 4.2. One of the studies mentioned that of the radiology report are written at below of 8th grade reading level. That means no way for the patient to understand the radiology report. So the patient struggles with the medical terminology. Yes, right. A lot of problems here. We have a technical language. We have a lack of context. Explain not the way that the language is written is not simple for them. And anxiety, including wording, for example, wording like a lesion, obesity, can cause fear, even when findings are benign. I met a lot of patients ask me, and when I read the report, I found it's just benign, but they were very frustrated and confused about their finding, and they were very worried about their health. So the key find, the numbers talk also again. 59.6% of patients cite unclear of technical language, unclear or technical language as the biggest barriers to comprehension. So how AI can help bridge the communication gap? AI can rephrase the complex report, yes, right, into the patient-friendly language by an NLP, neural language processing, and large language models such as ChatGPT, Gemini, I don't know, a lot of engines here now. the latest one, it's Seek Deep. I don't know, it's something like that. I have demonstrated the ability to summarize the report at the 8th grade level, and I have tested that, and it was true. Yeah, I tested with more than like 60 reports, and it went right when I asked the AI to facilitate it to the 8th grade. I mean, the AI facilitated to 8th grade, and I tested by some of my special tools, and exactly, yeah, it passed. AI can add explanation, definitions, contextual details to the report to reducing patient confusion. AI potential benefits: automated report summarize. Wow. Hyperlink medical terms. Wow. Visualized aids and graphs. Wow. It seems the problem has been solved. Will AI finally solve the understanding gap in radiology report? It seems great. Let's see what are the patient and radiologist think about it. Do the patient trust AI simplified their report? Mixed reaction. Patient appreciate AI as assistant, but still prefer human verification. As I mentioned earlier, when it comes to the health, patient only trust the human people. Common concern, fear for mistakes. Actually worried that AI lacks of personal touch. I mean, because the AI just give it straight to your face. They don't look to your emotion or emotional or stuff like that. Some of patients feel AI explanation might still be too vague. A survey, I mean, shows that most patients support AI in a secondary tool as a secondary tool, but want radiologists to verify AI generated summaries before release. Wow, the time is gone. So this is some of the references, radiologists. The growing role of the AI radiology. AI is revolutionizing radiology. AI enhance diagnostic accuracy and efficiency, automate lesion detection, image segmentation, anatomy. Patient potential for AI. They feel that AI is the simplified report for patient-friendly. This is some of the statistic. Area two of the radiologists believe AI will significantly transform radiology. Most radiologists agree AI will assist and not replace the human expertise. There is a sort of optimism and skepticism among the radiologists. Let's just, I mean, there is a difference between two generations. The early people, the senior different than the junior. The senior thinks that there is still a problem with it, need more time. But the junior is the opposite. But there is a lot of, they think there's so many barriers for adapting radiology, AI in radiology. One of the concerns is about the ethical and who's going to take the responsibility. And yeah, so will the AI become routine? We have 3 types of time, 3 to 5 years, and 6 to 10 years, and over 10 years. It seems like those who's working in very fast environment want much, or they have more optimism about the radiology report. But when you talk to interventional radiologist and cardiothoracic radiologist, feel like no, it's going to take more than 10 years. Expertise level. I mean, radiologists with more experience. We found that the junior also, we put some trick question in the interview, and the radiologist who has, like a senior radiologist, they were more able to detect the problems. In the other side, juniors, they couldn't find it. That means we have a problem with the new generation for adapter of thinking. What do they think about the radiologists? About AI. What the radiologists are asking for, 82 of the surveyed radiologists want structured training. And this is some of the barriers. They said they want more training to understand the radiology report, how to use the AI. And it has to be added to their education. Gender differences in AI adoption. Do male and female have the same feeling? I mean, like about the radiology, we found the male more optimism to adoption the radiology, but in the other side, 80.1 from different question. The female radiologists express caution and seek more transparency. Female radiologists may be more critical of AI due to the black box. What is the black box? Sometimes the AI give you some of vague conclusion. Even the expert, those who's very experienced or has more experience in or researcher in the field cannot understand how the AI comes with this. This is because so many problems. So many things. One of these things is that AI use very complicated algorithm to analyze their data. Its data, sorry. So that's one of the problems. So we're talking about the black box, mystery box that comes with the conclusion. That's one of the problem. And when it comes to health, it has to be verified. Developer must ensure the transparency and reliability. AI adoption, urban and rural. We found that there is some challenges between urban and rural area. People who live, radiologists live in cities and outside the cities. More optimism in cities and not that what I mean, they don't feel that. I mean, the opposite side, you can find it in the rural practice, people who live outside the cities. Summary, this is some of their problems. There's optimism, the barriers, training, diversity, and the future. AI must complement, not replace the human expertise. So let's go to the AI developers. When speaking frankly about their work in the area, tend to have mixed feeling, optimistic and realistic. AI is, and this is what the AI developer is saying, AI making progress, but not yet. That's what they feel. They're not there yet. Many of the developers acknowledge that while AI has advanced significantly in processing and simplifying medical text, it is still far from perfect. And so many challenges. One of the challenges is the language, that of the radiology, about the meaning. So the question is, what is the semantic and syntactic? I won't make it easy for you. Just go and read about these two things. And this is one of the big challenges for radiology, for the developer to facilitate it. So also the last mile problem is harder than expected. Still, I mean, they feel they did it and they have AI, but still there is a lot of challenges to adopt it. One of the problems, as I mentioned earlier, the jargon isn't just about complex words. It is about the meaning behind them. It's about the meaning. And also number 3, medical AI is held to much higher standard. Unlike AI used in a general application, medical AI must be extremely precise and trustworthy. It comes to their health, so they deserve to have much. So and the AI developers understand the patient fears about about their emotional and anxiety and etc. So they still need it. AI still lacks true understanding. They understand it, even they can simplify it, but still there is a big challenges for this. Patient expected more than just AI can deliver. They want the AI treat with them like a human, long-term optimistic and realistic for this. And there's a lot of limitations. They mention it. I don't have much time to talk about it. And there is an ethical problems. They feel it. One of the it's about the health. And the conclusion. One of the most important point that I want you to understand is that AI significantly, all of the patient radiologists, AI believe that AI should still, it should still a trusted support tool, but with a human oversight. That's the most important thing I wanted to. And this is some of my studies. I want, if you need more to read about my work. And please, if you are a PhD student interested in AI and healthcare informatics, please contact me, Dr. Mohammed Al-Arifi. I would love to add you to my ongoing project, and we have a lot of. I'm looking for PhD students and master students if they are willing to work hard, and AI developers and engineers with expertise in natural language processing and machine learning, interesting to work in radiology. And thank